do I just like do a piece?
Piecewise functions. That's what we're talking about today. Ladies and gentlemen, what is a piecewise function? Well, it's two or more functions graphed on the same plane, but they're graphed in such a way that you maintain the function rule. Now, you remember the old vertical line test that we had for a single graph? Well, we have to maintain that same rule here for the piecewise functions because of the word functions. So if I drag a vertical line across this graph that I have now, would you agree right now it's touching 1 point at a time, but at this point right here, all of a sudden we're touching 2 points at a time. Obviously the function rule's been broken. And even at this one, we're touching 3 points at a time. So the function rule's definitely being broken here, right? So even though I've got three pieces of three graphs, 1, 2, 3, that's the piecewise part, but I'm breaking the function rule. So how do I make this into a function? Well, we're going to do something called limit the domain of each function. So for example, this line right here, instead of having him go forever to the right and left, I might just cut him back so that he ends at -1, right? So he might be to the left of -1. This next piece, this parabola, for example, he might then start at -1. And he might only go to, say here, right? Where it ends at 3. And then I'll pick this piece up, and I'll have him start at 3 and keep going to the right. And now take a look. It looks like I've got a piecewise function here, right? 1 point, 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 oof. Right here, this border. This border looks like it's touching 2 points. Well, that's an issue for me. So here's what I'm going to do. I'm going to say that, and again, this is my choice, I'm going to say that this first piece, it actually goes to -1, but at -1, it doesn't actually touch -1. Now remember that empty circles mean that it goes to that value, but it doesn't actually touch that value. So I'm ending this first piece at -1, but I'm not including -1. So it goes all the way to -1, but it doesn't touch it. Now the parabola, I'm going to start him at -1, including him, and then I'm going to follow him until I get to 3. Now again, I still have that problem where at this point I'm breaking the vertical line test just at 3. So again, I'll limit his domain. This time I'm going to end his right side with an empty circle, and I'm going to start this guy, including him, and I'll go to the right. Now take a look. If I carried the vertical line test and I went across 1 point, 1 point, 1 point, 1 point, 1 point, 1 point, even at this one, am I actually touching 2 points? No, because this point right here, he's not included. So that's actually only touching 1 point. Again, here, only 1 point. 1 point, 1 point, 1 point, 1 point, 1 point, right? So that's just what a piecewise function is, right? Now, the limiting of the domain, right? Actually, let me first talk about where piecewise functions are useful. Think about your data usage, folks. Suppose I have a graph here, and I want to talk about how much data I use on my phone and the speed at which I can use it, right? I think you've all heard of the phrase, things like 4G and 3G and 2G, right? And then telegrams, right? Well, take a look at this. Suppose I draw a graph where the y-axis is the speed at which I'm operating. This is my G's, right? Or what do you guys call it, the LTE? I'm not real big on the technology there. And the x-axis is going to be how many gigabytes of data I'm using, whether it be streaming music off your Spotify or watching your Netflix or snap facing each other or screen chatting. I don't know what you kids do these days. Anyway, so let's suppose that you have a plan that starts off with 4 Gs and you're given 4 gigs of data. Well, starting at 0, you would go along the 4G until you get to this 4 gigs of data. At that point, they drop you down to, say, 3 Gs. From 4 Gs to, say, 6 Gs, they might give you 3 Gs of data. Or they might run you at the 3G speed. And then after the 6 gigs of data have been used up, for the remainder of it, maybe they run you on like the Telegram service, right? Where you're getting no Gs. In other words, you're probably just having to use your telephone connection, right? Well, this is a piecewise function. Now, let's think about the borders where the 4G, for example, ends and the 3G starts. Well, when you reach this the 4 gig spot, do you stay at 4Gs or do they drop you down? That's right, they drop you down. So at 4 gigs of data, your 4G speed would be empty and your 3G speed would start. Similarly, at 6 gigs of data used, you're no longer at 3 gigs or 3Gs. They bump you down to say 0, right? And then you'll stay 0 for the remainder of your month, right? And that's an example of piecewise functions. There's all sorts of uses of piecewise functions in the real world, right? Now, again, if you take a look at this, isn't it the telephone company or whoever your phone provider is? They're the ones who set the interval or the domain in which each graph is graphed. In fact, and don't lose sight of this, these are just 3 horizontal lines, right? So someone said, all right, start your gigs at 0 and end at 4 gigs, right? Then go from 4 gigs to 6 gigs for the next bracket of 3 gigs or 3Gs, right? And then after 6, they drop you down to 0 Gs, and then you're just using your phone, right? Okay, so let's take a look at that of the limiting the domain of a function. Folks, limiting the domain of a function is where you pick an interval for your x values for a particular function that will be graphed. What that means is your graph can only be drawn over these x values. So let's take a look at this problem right here. Suppose I want to graph y equals 2x plus 1, but my domain restriction is x has to be less than 0. Okay? Well, what that means is, if I go to graph this, well, let's see. I know that to graph this is y equals mx plus b form, so I know my y-intercept would be 1, or 0, 1, and my slope says go up 2 and to the right 1. Up 2 and right 1, right? And if I drew that line, it would look like this. Now, that's how we drew them in the old days. But what's the problem with this graph that I've drawn? What's this domain restriction? The domain restriction says my graph can't exist except for x values that are less than 0. Well, where does x equal 0? Right here. So all this to the right of 0, all these numbers where x is greater than 0, that can't be there, right? So the graph would have to look like this. So how should I have graphed this? Well, let's take a look at this. Well, let's see if I can do this again. Well, my y-intercept is 1, so I'm still going to go to 1, put a point. But instead of going up 2 and right 1, couldn't I have gone down 2 and left 1 using the slope? And by doing that, I stay within the domain restriction of x's have to be less than 0. Now, I'm going to put my pencil at the y-intercept, at that border value of 0, and I'm going to draw towards the domain that I'm given, less than 0. Now, I know you're all thinking, but wait a minute, Mr. Kong, what about that y-intercept? Should this graph actually be touching 0? No, because it's not inclusive, because it's just less than 0, at that y-intercept of 0, 1, that point needs to be an empty point. Now, notice that I have to take the line all the way to that border value of x, because it can be like a half, or negative a half, I should say, or negative a fourth, or negative an eighth. So you have to take the line all the way to that border point. It's just whenever this domain is exclusive, we use an empty point to represent that point's coordinates. Okay. Now, let's take a look at what a piecewise function looks like in equation form, right? Piecewise function in equation form might look something like this. Now, in this problem, I've got 3 pieces. I've got the first piece here, 3x minus 5. I've got the second piece here, x squared plus 4. And I've got the third piece here, the 1/2 x minus 2. When do I use the first piece? Anytime I have an x that's less than or equal to negative 1. I use the second piece whenever I have an x between negative 1 and 3, including the 3, but not including the negative 1. And then lastly, I use this third piece for any x value that's greater than 3. Okay? So, if I'm told to evaluate this piecewise function for f at negative 3, let's look at first example A. Well, that says I'm going to plug negative 3 in for x. But which of these pieces should I plug it into? The first, second, or third? Well, since negative 3 is in this guy's domain right here, this is use the first piece. So f at negative 3 would equal 3 times negative 3 minus 5. So when you do the math, does everybody agree that's negative 14? You guys tried B on your own, and I'm going to do C now. For C, f at negative 1. Well, wait a minute. I've got a problem here. For negative 1, let's see. Ooh, this is negative 1 here, but that's negative 1 here. Which piece do I use? Well, if you think about it, doesn't it say to use the first piece when x equals negative 1? The second piece will not be used when x equals negative 1, right? Because it's not inclusive. So I know that I have to use that first piece again. So when you do that, you're going to get negative 8. Now notice, ladies and gentlemen, that where one piece ends, the other piece begins. If this piece ends at negative 1, the next piece will pick up at negative 1. This piece ends at 3, the next piece picks up at 3. Also notice that when one piece is inclusive, the other piece has to be exclusive. Inclusive, exclusive. Right? So you'll never have any contradiction or confusion on which piece is being used. You can only use one piece at a time. All right, you tried D on your own. D is like C. All right, now, so that's how you evaluate piecewise functions. Let's go to graphing piecewise functions. Graphing them, they can be a little bit tricky. So what I've done is I've given you some steps here to go through. You guys can read these steps on your own. Pause the screencast and you can write these steps down. All right? Now, I want to graph this piecewise function right here. Everybody see this? Okay? So I've got f of x equals 2x plus 1 and f of x equals 1/2 x plus 3. So if everybody looks, I've got two pieces, the first piece and the second piece. So the first thing I'm going to do is I'm going to split my piecewise function up into the individual functions. Y equals 2x plus 1 and y equals 1/2 x plus 3. Now both of these are lines. To graph lines, I know I need 2 points. All right? Now, to graph a line, couldn't I pick numbers for x, plug them into the equation and figure out what y is? Well, in step 2, I'm going to make an xy chart to do that. So to graph a line, I need an xy chart. I need 2 points. For this line, I make an xy chart. I need 2 points. Now, the first x I pick. The first x I pick has to be what I call the border x. I have to take this piece all the way to where it should stop. Well, in this case, it says the x has to stop at 1. So I'm going to plug a 1 in for x. Well, doing the math, if I plug this 1 in for this x right here, does it make sense that I'm going to get 3 for y? If you need to stop and do that on your own, do that. Well, now I need another point. But when I pick this value of x, according to my notes, I can pick any number I want as long as it's in the domain for that function. All right? So let's see here. Well, since I have this function, this piece can only exist for numbers less than or equal to 1. I've already used 1. Well, now I can pick 0 for x if I want. If I put it in 0, does everybody agree that I'm going to get 1? Okay? Now let's go to this next piece. Again, the second piece, he also has a border of 1. So I'm going to start at 1. By plugging 1 in for x, 1 times 1/2 is 1/2, and 1/2 plus 3 is 3.5. So 1 comma 3.5 is a border point. Right? Now I've got to pick another number in the domain to graph my line. I've got to pick a number that's greater than 1. So I'm going to try 2. Plugging in 2 for x, I get 1/2 times 2 plus 3 for y is 1 plus 3, so 4. So when x is 2, y is 4. So I've got my 2 points for each piece. Right? I've done step 4. Now I need to graph the 2 points for each function. Now here's where you got to be careful. You need to be careful when you use empty or closed circles. Well, think about it. This first piece. let me erase some of this work so that we can focus just on the graph now. Okay? This first piece. When I take this line all the way to this value of x, should it be touching that point of x equals 1 or not touching it? It should be touching it because of the inclusive. So this point 1 comma 3 will be a solid point. I know that. So when I go over 1 and up 3, that point will be solid. Now the other point, 0 comma 1, he's already in the domain, so he's always going to be solid. The only point that ever could be empty would be a border point. Now, after I graph those 2 points, to make sure that I do not escape from my domain, I connect the points, but I start with the border point and go towards the other point, so that I don't make sure, if I just draw my line, if I do that, that's no good, because if you look right here, I've gone outside my domain, so I don't want to do that. All right? What I'm saying you need to do is, you need to put your point at your border, your pencil at your border point, and then go towards the other points. That's the first piece. Now I graph the second piece. The first point for that is 1 comma 3.5. But remember, at 1, this point is exclusive. So when I go to graph 1 comma 3.5, 1 comma 3.5 should be an empty point. So when I go to graph that empty point, I'm going to use an empty circle here. All right? Let's take a look at this. When I graph this, I'll draw an empty circle like this, okay, at 1 comma 3.5, and I don't like that, so let me just draw it by hand. Let's take a look. So by hand it would look like an empty circle like that. That's not right. Empty circle at 3.5, like that. Now the next point would be 2 comma 4, which would be right here, and that would be colored in. Now putting my pencil at the border point and going towards the other one, I get a graph that looks like that. Now I've drawn my piecewise function. The last thing I need to do is I need to make sure that what I have is still a function. After I've graphed my piecewise function, make sure and check using the vertical line test to make sure that you're still following the function rule. So imagining my vertical line here, dragging it across. Let's see, no points on 1 point, 1 point, 1 point, 1 point. At that border, that's only 1 point since one of the points is empty. 1 point, 1 point, 1 point. And that's how we graph piecewise functions, right? If you want, try doing this one on your own. We'll talk about this as a group on Monday. Have a good weekend. Thanks for the 18 minutes of your screencast time. Thanks. See you Monday.